going to start off with a little presentation, which is just going to expand a little bit on what Fiona's said in the introduction there, and thanks for that. As you're here, I suspect you all know what Google Earth Engine is, and there it is, as Google describes it themselves. But splitting it up into two sections, really, we have got the data catalogue.
Johnny, sorry, we can't see anything if you were showing the slides.
I do beg your pardon. Let's try that again. Bear with me. How's that?
Much better. We can see Excellent. It now. Thank you.
Okay. Good news. That would have been a very well, undescriptive presentation. So yeah, the Google Earth Engine will be split up into a couple of sections, really. So we've got the data catalog, and as Fee said, I think it's up to around about 80 petabytes of data now, and my little brain just can't really comprehend that much data. And we've got global data sets, all the data sets that you'd imagine, all the free to download ones, so Landsat, Sentinel, also elevation data, and then information derived, so land cover maps, land use maps, an awful lot of global data sets, some more specific esoteric data sets as well. So maybe if you're interested in cocoa plantations in certain South American countries, Google Earth Engine's got your back covered for that kind of data as well. I'll show you how we can search for that data in a little bit. But the second part of the Google Earth Engine is the processing bit. And so here on the console, we can use around about 800 processing functions. And so that's both on images and features, vectors. And in fact, a lot of those functions are very, very similar, if not pretty much identical to the kind of operators that we have in ERDAS IMAGINE Spatial Modeler. If you're a programmer, this is great. Knock yourself out. JavaScript, Python, you can just do it straight in the console there in JavaScript, or you can use your Python interface of choice, and away you go. That's great. I'm not entirely sure I agree. So this is lifted straight from a Hexagon presentation. I'm not entirely sure I agree that a small number of geospatial workers are programmers nowadays. I think if you're, shall we say, my vintage, I think that probably holds true. I think the younger generation coming through probably are much more program aware. And also, of course, we've got AI to help us out, which is my method of choice. And so if I need to do some programming, then I'm straight onto AI to try and get something there, and that works. That's fine, and I've tried it in Google Earth Engine, and that works as well, and that's great. And so if you're wanting to program in Google Earth Engine, fab. If you're not, then Hexagon have done something that is potentially very useful. And so all of the data sets and all of those functionality can be accessed using the REST API, and so you get a little JSON snippet for all the functions and data sets within there, and that can simply, maybe not simply, but it can be automated so that all of that functionality can be converted pretty simply into a operator that can work within Spatial Modeler. And also, in addition to that, it can automatically generate some help pages as well. And so it doesn't leave you hanging. The help pages, as automated, useful, but the ones which have had a little bit of human interaction are way more useful. And so there's kind of a two-tier help page for the live link operators within Imagine. We'll have a look at that as well. And so here we have an Earth Engine expression, and I'll make a note of this because I'll be doing something similar live in a second. But we have an input, we have the band selection, we have some operators, and we have the output there. Let me just end the session now. Bear with me. Okay. Cool. And then we can go to Spatial Modeler. So again, if you're here, you're certainly hopefully aware of ERDAS IMAGINE, and hopefully you're aware of the Spatial Modeler. Spatial Modeler, the vast majority of the development work within ERDAS IMAGINE has been focused on the Spatial Modeler over the last several years now. It has pretty much all the functionality that's available within the ribbon, but in a very, very intuitive interface. And so all geospatial software has something like this, a graphical modeler. So you got it in QGIS, got it in ARC, Esri, of course, got it in Snap. They all have something similar, of course, FME, of course. I'm slightly biased here, but I think this is probably the most intuitive of the graphical modeling interfaces. When I'm doing training, it's an absolute joy to see people starting off at the beginning of the first day without knowing what it is, and at the end of the first day doing really good models that sometimes are focusing exactly on their workflows. And so it really is pretty simple to get up to speed in this. I'll just show you how it works in the normal course of events. And so here we've got a Sentinel-2 image. There's so many operators. I always go for the search to find the operator that I want. So here we're just going to find, select band 8. I'll do it the easy way, which is the near infrared band. We're going to search for band 4 here, and then we're going to divide those two. Simple drag and drop between ports. Nothing too special going on there. And then we want to multiply. Oh no, what am I doing? I've forgotten how to do an NDVI. My bad. Let's go for the real one. So we're subtracting the visible red from the near infrared, and then we're adding the visible red and the near infrared, and then dividing those two. And then the great thing about Spatial Modeler is that you have this function, which is the preview operator. So I'm going to hook up the original data set to the preview. I'm going to add in another port, which enables me to add multiple data sets into the preview. And I'm going to click on that. And here we have an image over the south of England, and the original image. And here we've got the NDVI. And so the Spatial Modeler is fantastic for prototyping workflows and being able to visualize the workflow on the fly as you go through. And so that's perfect for local data. Let's have a look and see what we've got when it comes to the live link. So as I said, there is an awful lot of operators within here. But if you hook up your Google Earth Engine account into Imagine, and the way you can do that is if you go to File and Configuration and Configure Earth Engine, you have to get a little JSON file from Earth Engine in order to do that. But it's pretty straightforward and the instructions pretty clear. If you do that, then hiding behind this unassuming Earth Engine bit is all of those 800 operators that have been automatically transcribed into Spatial Modeler. So the first thing I'm going to do is just do probably the simplest model that we possibly can, which is preview an image. So let's have a look. If we click on load, then we have an image load. And in best demonstration style, I have got an image already prepared. There we go. Let's just run that to see that it's okay. It is. Google Earth Engine likes data with all the same spatial dimensions. And so Sentinel-2, of course, has bands at 10 meter, 20 meter, and 60 meters. If you try and view all of those at the same time, it'll throw a wobbly. So let's just select, let's go for the visible band, shall we? There we go. And so anywhere you see one of these little multicolored cog operators, that's showing you that things are happening on the cloud in Google Earth Engine. And so selected band 4, band 3, band 2. Let's run that to make sure it works. That's fine. And then we can convert that to a raster. And so this is where it pops off the cloud and comes back down onto the local machine, its memory. And then, oops. Then we can hit the preview. And have a look and see what we have. Oh, and there we go. That's the same image that we were looking at to do the NDVI, but taken directly from Google Earth Engine. I don't know about you guys, but I find it a real pain to having to, well, one of my pain points is actually getting data, and so downloading it from well, wherever you want to download Sentinel or any other free to download remotely sensed data. And this is a really neat way of being able to get hold of the data you want. And I'll show you in a little bit how we can actually find data rather than having the ID already available to us. Let me just clear that now. And we don't want to have a look at that. So finding data, let's go and have a look and see what Google Earth Engine looks like on the web. So here's the data catalog, and we can see it's got some highlighted data available to us. We can look in categories as well. So I'm not going to go through all of these because you can perfectly capable of doing that in your own time. And then we've just got a list of all the data sets as well. And yeah, there we go. As it's at the top, let's have a look at, okay, let's have a look at this one and click in. And then it gives us some information about the data set. That's great. It gives us the terms of use. It's open data, perfect. It gives us some information about the bands as well. But it also gives us an Earth Engine snippet. And this is really interesting to us because what we can do is we can just copy that and paste it into there. And there we have it. It automatically creates a load Earth Engine operator. And so we can have a look at that. And again, just simply hook that up to there, hook that up to the preview, click on preview. And wait a little bit, there we go. It's a bit dark, hang on a sec. Let me just zoom in and brighten that up. Honestly, there's elevation data there. Let me just show you how we can get that. Just radiometry. And should we put a basic cause in? There we go. We can start to see the data there. But of course, because it's in the preview window, we can do all our usual enhancement there. So we can change it from displaying as panchromatic. We could put it as pseudo color. I'm going to put it, because it's elevation data, as relief. And then that'll come in again. And we can use color as well to help to brighten it up a little bit. Let's go for elevation. There we are. And also, it's in the viewer, it's in preview. we can actually inquire the data, of course. And here's the pixel value, minus 1.61. It's the Netherlands. It's below sea level. Yeah, so we have all that functionality that's available to us. So once we convert the image to raster, as you'd expect from any data set that we were using locally. Okay, let's close that. Let me clear that as well. And let's go back and see whether we can find some data. Let's go back to all data sets and see what's available for the UK. Okay, we have a 1 meter composite digital terrain model and digital surface model. Let's go and have a look at that. And again, we can take the snippet, but first of all, okay, so what bands have we got? We got a DTM, a DSM first and DSM last. So we got first returns and last returns from the LiDAR to produce the digital surface model. So 3 bands, and then we'll take that snippet, pop it in there, and let's have a look at some information about that data set. If we run just that, we've got a key piece of information coming up here. It's not homogeneous. And so similar to Sentinel-2, we've got different widths of the data and possibly different pixel sizes as well. And so we can't go straight to a convert to raster. We're going to have to select which band that we want to use. And so let's go there. And handily, if we have a look down here, view the data, we have got the ID of DTM and DSM first. So it gives us the band ID. So let's have a look at the DTM. And then we can convert to raster. And guess what? Let's have a look at it. And there we go. We have the DTM, the whole of the UK, just brought in from Google Earth Engine with no trouble at all. If we actually want to do something with this data, we absolutely can. And so if we want to maybe, let's get rid of that, do a relative height model. And so we just want the heights of bits sticking up above the Earth's surface, whether it's buildings or vegetation. Well, we can. Let's copy and paste that in. And instead of DTM, then we can have DSM first and hook that up there. And then we can subtract. Those two. And then we can preview that. And there we go. In full honesty, I was going to do something, a fake mistake there, which I've actually completely failed to do. I was going to use that subtract operator straight from the image select. You can't do that. You can't kind of mix and match Google Earth Engine operators and local operators. And so another way of actually doing this is doing the processing locally. If we do it on the cloud, we absolutely can. Let me just clear off the preview there, and so it won't go throw wobbly if I do that. If we put a image subtract operator in here, then we can hook up that to there. We're just creating the one conversion, and then out to preview. And that's producing the same data set. Voila. Excellent. Okay. Of course, again, we can zoom and style this operator or this preview window. It is with my connection at the moment a little bit more slow than doing it on local data. You can see that as I'm zooming around, it's not the instantaneous kind of display that you're used to with local data, but at the same time you're pulling down gigabytes of data from the cloud, so swings and roundabouts, I guess. And here you can actually see that the relative height model is actually showing what we thought. Have we got any buildings coming up here? We've certainly got some vegetation. Yeah, you can see that that's kind of trees. In fact, that's all trees popping up out of the ground. But again, we can inquire on that, and so that should be close to 0, where the DSM and DTM are fairly or equal-ish. And then if we head out over to a tree, that tree is 25 meters tall, so quite large. And we have got 1 or 2 little buildings in here as well. Okay. So the last thing I'm going to do is to have a look at how we can use collections. And so an image collection is a group of similar data. And so the Landsat 8 TOA collection would be all the Landsat 8 TOA data sets available within Google Earth Engine. So tens of thousands, hundreds of thousands, more individual data sets. Let's have a look and see how we can do that. The first thing we want to do is to load an Earth image collection. And so there it is. If we double click on that, we can go to Copernicus, and then we have a look at our Sentinel-2 harmonized collection, and we can click OK. Other way of doing that is just to go back to the web and go to, let's have a look, Sentinel. Am I going to be able to find it? There we go. That's our harmonized Sentinel-2 data set. And so if you take that snippet, actually, let's try this. Copy and paste into here. There we go. Exactly the same thing. You can either browse through the operator or copy and pasting, so that's fine. If we run this, that's going to give us every single data set in that collection. Possibly interesting, probably not. We want to be able to filter that down to something that we want for our own purposes. And first 2 ways of getting it down would be to define, to filter it both spatially and temporally. And so the first thing we want to do is to put in some spatial filter. And if I have a look for here, we should have a geometry point. So I'm just going to put a point in. By default, it goes to lat long, and I'm going to put in a point which is close to where I am, not exactly. And so minus 0.5 plus 51.3. Okay, and then we can filter that by bounds. So image collection, filter bounds. And go there, look up the geometry, run that. And now we've already got that down to only the data sets that intersect with that specific geographic point. The next thing we want to do is to filter by date. So let's go to the image collection filter date. There we go. And we can set that going from start, maybe beginning of May. to today. Why not? Okay, and run that. Excellent. Okay, so now we've got just the data sets that intersect with that point and from the beginning of May this year. We also could do a little bit of filtering on cloudiness. And so we have been fortunate in the UK or in England this summer that we've had loads of cloud-free days. Okay, fortunate for image acquisition, not so fortunate for those without air conditioning, which is probably most people. But we can filter on cloud, on any of the metadata within this collection, and I'm going to filter with a cloudy pixel percentage of less than. Actually, I'm going to change that to less than 3 because we have had so many good cloud-free days. And if we run that, then we have filtered down our collection really nicely now. So this is going to give us a list of all of that data that satisfies those conditions. There are more, or there are better ways of getting the image that you want out of here, but for the purposes of this webinar, I'm just going to pick the first one off the top. And so we got an image collection first. And there we go. If we run that, cool. And then we can go back and convert to raster. And then we can have a look and see what we've got. And I know what I've done wrong there. It's Copernicus. I can't view the whole thing at the same time. I need to select those bands. So again, I'm going to select the visible bands. And now we should be good to go. And guess what it's going to be? Guess what it's going to be? It's going to be, it's the same image again. There we go. So this is essentially how I got the ID for that image. And let me just show you how we did that, because we can have a look at the image ID. Let's look. We've got ID. Image ID, there we go. And so you can find out what that is. It's a string expression, and then I've got get that as a value. And run just this, and there we go. There's our image ID that I used previously. Okay. Yeah. We could look at adding in a NDVI. In fact, okay, let's do this in best old school Blue Peter style. Here's one I prepared earlier. And so this is exactly the same model, except we've got the NDVI coming in here as well, converting to a raster. So if we preview this, then just to tie all the ends up, we've got exactly the same model using Google Earth Engine as we had that quick model I demonstrated to you just using the local data. So NDVI, and again, we can swipe that. Voila. Exactly the same, but using Google Earth Engine data and processing. Cool. I'm just going to go back to the PowerPoint presentation for a second. So we've looked at some of these operators. Actually, we've really just looked at the data discovery and loading. We can do more. We've got the request information as well. We can do more, and so we can look at including algorithms as well. So instead of using an algorithm just on one image, we can do it across a collection of images as well. And I think I've got an example of that. We do, I'll come to that in a second. We can also combine cloud data with local data as well. And so here we're doing a NDVI, and then we're applying that NDVI to polygon data. I really want to run through this. Yeah, why not? And that's going to be useful because there's going to be maybe data that you don't want to upload to the cloud or is just easier to use locally. And so you can absolutely do that. So you have that facility to combine Google Earth Engine data sets and local data sets very, very simply within the Spatial Modeler. And so that's quite a neat application. And of course, because you have the access to the vast data sets within Google Earth Engine, then we can very straightforwardly scale any algorithms that you have created. And so we go through the process. We can either directly map or we can use an algorithm. I'll just show you an example of that in a second. We reduce, a reducer operator takes a collection and reduces it down to one data set. We saw that as well in the image collection first operator that we used. And then we get that as an output. So this is where we can create an algorithm. And so we've created an NDV. It's not an NDVI, it's band 5 over band 4, but we've created a ratio in the examples I've shown. But if we want to apply that to multiple data sets, instead of having a load Earth Engine image operator, we can have an Earth Engine algorithm input. And then we can incorporate that into the collection. We've done the filtering on the collection, and we can run the algorithm over all of the filtered data points we have coming out of the collection. And so we can run that indices on everything. We can map it. Here we've got a reducer, which is a median. That's fine. And then convert to a raster and output. And so you're not limited to processing an individual image at a time. Using the algorithm approach, we can do multiple data sets. And I will not look at this because it's not that interesting. And also, once you have an algorithm that works, then we can go on to batch, and batch is going to be good because it's cheaper. And so rather than running on demand, which can cost a little bit more, if you use a batch queue, then they're lower priority, but also much cheaper as well. As Fiona said at the beginning, the live link is now going to be included in the chest package. And in fact, come the next release of Imagine, that's coming out in hopefully Q3 this year, then instead of being an add-on that you have to pay for, then it's going to be included in the professional tier from that release onwards. You do need an Earth Engine subscription. If you're in academia and non-commercial, then that's freely available. If you're commercial, then you have to pay Google for the privilege of that. But Hexagon have been and will be offering preferential subscription, and so you'll get it a little bit cheaper going through Hexagon than if you go direct to Google. And then you help Hexagon out as well, which is lovely. And there we are. Okay, that's actually taken a little bit longer than I was planning, but that's fine. Let's end that slideshow there. And that's pretty much it from me. So I can now skip to any questions that may have popped up during the presentation, or any questions that you have now.
We haven't had any during, Johnny, so I'm hoping there might be a couple now. I was going to ask you what the benefits or the difference are between doing your processing on the cloud and doing them locally?
Okay, it's an excellent question, Pete. So if you have a small amount of data, then no problem doing it locally. And if you're prototyping a model, then again, no problem doing it locally. If you're wanting to process vast amounts, gigabytes of data, that is going to overwhelm you trying to process that locally, then that's where you probably want to switch to the cloud and probably want to switch to batch processing as well, so that you keep the processing costs down. And so everything here it didn't really make an awful lot of difference whether it went on the cloud or it went locally, because it was very simple, not very large data, comparatively not very large data sets, and so not to worry. But yeah, if you're wanting to process vast amounts of data, then doing it on the cloud, batch processing it will be the way to go.
Okay, thank you. And I've got one other question that's coming is, do we do any training?
Yes, we do. Both generally on ERDAS IMAGINE and other Hexagon products, and also more specifically on Google Earth Engine. So Google Earth Engine, we don't have a course per se, and so pretty much like all the other training that I do, if you're interested in training, then tell me what you're interested in, and we can get together a course specifically, or that addresses your specific needs and requirements. Hexagon do general courses, and sometimes I use that as a base to just kind of get started. But on the whole, I find it a lot easier to have a specific course for people's specific requirements, and even better, use their data in the course as well, because then people can really relate to it and get up and running quickly.
Brilliant. Okay, and we've got another question. Thank you for the webinar, first of all, Johnny. Yep. And can you remind us which version of ERDAS all this functionality will come in?
Okay, at the moment it's an add-on. You probably don't have it unless you've specifically requested it as part of your academic chest detail. With chest, it will come as part of the chest license from the next renewal, and from the next release of Imagine, which isn't that long away, like I say, Q3, they generally do it around about October, then that will come in the professional tier of Imagine. And it's in the professional tier because it's part of Spatial Modeler, and Spatial Modeler requires professional.
Okay, thank you. So for chest users, you're getting a little bit earlier for free. So we're processing all your orders, your new licenses now, because you're due to receive them 1st of August. So that will come in with the package that you get, and it will be available in your license portal for that. And then if you're a commercial organisation, then you'll be waiting until the next release, like Johnny said, later in the year. Going back to the training, over the years, Johnny has done quite a few little 2-minute tips. They're available on our YouTube channel, and they might be interesting for you for different snippets of different functionality, and we'll just put that link in the chat now.
That's a good point, because the next tip and subsequent tips, well, you'll certainly recognise the next tip when it's published shortly, but over the next couple of months or so, I'll be putting more tips out specifically for Google Earth Engine as well. So that's why my focus on the videos is going to be over the next couple of months.
Brilliant, thank you. And then also, if you need any technical support, so often Johnny's a bit busy in August when everyone's getting their new licenses, but if you need any technical support, whether that is licenses or you've got questions on functionality, on anything within the software, then don't forget his email is support@geospatialinsight.com, and either Johnny or one of the team will pick that up for you. And if you've got any queries on what's included in your chest package, then we've also popped in the link for the Hexagon agreement there from the web page. So are there any other questions at this point? I can't see anyone typing. So thank you very much, Johnny, first of all. And thank you everyone for joining. I hope you found that of interest. And it was a useful starter for you. If you've got, as I've mentioned, we've got the 2-minute tips, we've got the webinars, we've got Johnny does knowledge sharing sessions, and there is also the formal training. But also what we're interested from you is if you've got any case studies that we can use either in our newsletters or in our on our blog, and it will just promote you as well. And Hexagon do tend to pick up a lot of these posts that we put out for social media, so it does get an international audience for us. They're very good at that. Johnny will be back doing another webinar in the autumn. That will be on ERDAS Apollo. That is a different piece of kit that is in your chest package under the enterprise option. Apollo has seen a major update over the last couple of years with the integration of Luciad technology. It's almost like a brand new product. So if you're interested in anything for data management, it might be worth sitting in that. But we'll send you an invite to it. We'll also send you a feedback form, and we'd be very grateful for your feedback. We're always looking to improve the webinars, and also on there, if you've got any topics that you'd like us to cover or in a 2-minute tip or anything, please add them on, and please tell us if you've got case studies that we can work with you on to develop. So that's great. So thank you again for all joining. I hope you enjoyed it, and we look forward to seeing you all again soon. Thanks very much. Bye.
Cool. Bye.